Hello friends, welcome back. The discussion is going to continue here. We are going to see the next set of questions on the data science, ML and DL interview readiness series. I hope the series has been useful, and in case you have questions, suggestions, please go ahead and type it in the comment section. I will be able to help you. First question, differentiate the regression and classification ML techniques. Please understand one very important point. Both regression and classification come under the supervised approach. Please understand they both come under the supervised approach. Whenever you talk about the supervised learning approach, it must be understood that we will have to train the model with labeled dataset. One has to specifically provide correct labels, and the algorithm gets the further learning from the labels. If your labels are discrete values, then we call it classification problem. If the labels are continuous values, then we call it regression problem. The number of children, as you can see, is a classification, which means they are discrete. If you think about the height or weight, that could be continuous. That's a simple way you can understand the difference between the discrete and continuous values. And remember, if the labels are discrete, we call it classification. If the labels are continuous, we call it regression problem. It's very important. Can you talk about the recommender systems? The recommender systems are the subclass of information filtering systems. They will provide you the information that you are looking for. They will predict. That's what the recommendation system is all about. One simple example could be the Facebook predicting your friends and recommending you the friends. Netflix predicting which movie would be of your choice based on your previous history. Amazon predicting you the products that could be of your interest. All these are simple examples that you can understand. Define collaborative filtering. Well, this is a very important question. Collaborative filtering is a very simple approach where the system would give you some results based on what other similar users like. For an instance, I have got one person here, he is watching my channel, and there is another person who has got the similar attributes, so my system would suggest my channel to this guy also. It is like this guy telling this guy, bro, I watch this channel, you can also watch. It is the recommendation based on the users who are similar. I understand what the users are all about, I understand the attributes of the user, and I provide the similar recommendations. That is called collaborative filtering. Now, what is content-based filtering? This is very simple, different from the previous one, and in this approach, we look at the item level, recommending on based on the similar items. It is not at the user level, instead it is on the item level. So I will check item 1, I will refer you item 2 based on item 1. It is at the item level. One simple example could be, I am a person, I read cricket news A, and now what happens, I am recommended with cricket news B and C as well because I like cricket news A. This is what is called content-based filtering. Remember it, and that's a very important question. Mention the well-known classification algorithms. Support vector machines, KNN, kernel SVM, logistic regression, naive Bayes, decision tree classification, RDF, random forest classification. So all these are very important, and they are listed as the most famous and the most common classification algorithms. Can you talk about SVM? This is a very important question. Wherever you go in the interview, this question is quite common. And what is SVM? Can you talk about it a little? That could be the question. Now understand, this is nothing but support vector machine. The data scientists always say that SVM is always offering you best accuracy when you compare it with other classifiers. This is most commonly used in the email classification. For an instance, I can classify the email as spam or legitimate using SVM. Now this can be used for both classification and regression problem, but most commonly we prefer it for the classification problems over the regression problem. Now the main aim or the target of the SVM is all about creating a line, an optimum line or a decision boundary. The decision boundary will be helpful in segregating the data set into the classes, and any new data which is entering shall be classified into whatever appropriately it has to be in the future as well. So the decision boundary is going to help you in classifying the data. The appropriate decision boundary is called as hyperplane. We will see a question about that hyperplane shortly. Now understand what is it? Very simple. It can be used for regression and classification problems, but mostly it is used for classification. It classifies an email as spam or legitimate, as I told you. I'll draw a decision boundary, and with that I can say this is okay, this is not okay. That's it. It's a very simple thing. Now, define hyperplane in SVM. This is the question that I started talking about in the previous question, but now we are going to complete it. Very important question it is, what is hyperplane? It is the plane which separates the object that belongs to different classes. You can see that this is the hyperplane that we are talking about, and red stars and green triangles are classified and grouped properly, and this enables grouping. This line enables grouping, and that line is called hyperplane. Remember it, this is a very important question. Define support vector. This is again yet another very important question when it comes in SVM. You can see the picture. In the picture, the red stars and the green triangles are shown, and they are all nothing but the support vectors. Remember, the red stars and the green triangles are the support vectors. These are all very close to the hyperplane, as you can see. These data points are the one which could actually decide the fate and the position of the hyperplane. Since these points are gonna decide, these points play a role in deciding the hyperplane's placement, we call it support vector. It's a very important point, remember it. Define margin. As you know, what is margin? Very simple, it is the gap. It is the gap between two classes. Now you can see that if the margin between the two classes is larger, then it's a good margin. Otherwise, it is considered bad. Now you can see that margin is a gap between two lines on the closer class points. You can see in the picture, we have drawn the margin there, and that margin is nothing but the gap between two classes. That's it. You can understand this easily on seeing the diagram. I hope the session was clear and easy for you to understand. In case you have questions, you can type it up in the comment section. I'll be able to answer. Thank you very much for following the channel and the content. If you have any feedback, suggestion, please type it in the comments. If you like the channel and the content, please give a thumbs up and subscribe. Thank you.